My name is DaShaun. I'm a Spring Developer Advocate. I work at VMware Tanzu. I love my job, and I'm jazzed to be here. I love this conference. This is definitely one of my favorite conferences, and yeah, this is going to be fun. This is something that I enjoy doing. This topic is something that I've spent a lot of time on since before the native image support came with Spring Framework 6 and Spring Boot 3. I've been in this space. I like the Spring Native experimental project. Today's day 1173 in this role, so just over 3 years. Before that, I worked at a company called Redis, and I was a solution architect, helping companies go from 2 millisecond latency down to 1 millisecond latency. Before that, I was a platform architect at Pivotal. So the biggest compliment that I got when I was at Pivotal was, hey, aren't you on the Spring team? I was not on the Spring team when I was at Pivotal. I was on the sales side doing Cloud Foundry. I still love Cloud Foundry. I have it running on my laptop now. But that was a big compliment. And now I'm on the Spring team, and I've always been doing Spring. I love Spring. Before that, I was at Mobile Capital Group, took Spring to production, took Cloud Foundry to production. It was a blast. But where I really learned a bunch of the challenging enterprise-grade global problem set was when I was at Garmin Connect. I was there for about 6 years. I do office hours. Office hours is a conversation. It's on every Monday, typically at 1 o'clock Eastern, 12 o'clock Central, with me and Dan Vega, another Spring Developer Advocate, and it's a live stream. It's the thing that I wish that I had when I was in your seat, when I was a developer. I wish that I had a channel where I could just go and ask questions. I wish I had a way to keep up with the latest things that are going on in our ecosystem. So that's Spring Office Hours. You can find it on YouTube, on the Spring channel on YouTube. All of my links are at DaShaun.com. My LinkedIn, my Gitter, my GitLab, all of the things are at DaShaun.com. So yeah, connect with me. This is a small group. We should be able to get through all this content, no problem. This is my house. When you come to my house for dinner, if you leave hungry, that's your fault. Today, we can have a conversation. You've got a question, raise your hand. If you've got questions, don't leave without getting your questions answered. Don't leave hungry. This is a Raspberry Pi. Raspberry Pi is a single board computer. I show this in a lot of my sessions. I spend a lot of time on these. It's a small footprint. Doesn't take a lot of energy. But now I can run enterprise-grade Spring Boot workloads on a small device, on this single board computer. I can run them at the edge. This is a Raspberry Pi cluster. That is 5 Raspberry Pis connected together, which I can make a 5-node Kubernetes cluster out of for $150. This is cool. It's a nice little toy for experimenting. But again, I can run Spring Boot workloads on here because of the native images, the native image support that we got with Spring Framework 6 and Spring Boot 3. I don't have cloud money. That's just not me. I have Raspberry Pi money. So, GraalVM. How many people are familiar with GraalVM? That's why we're here. Hey, GraalVM's a thing. It's been around for a long time. I think it came out in 2015. My first interaction with GraalVM was with a team that was trying to build native images, and they were running into problems. The JVM image worked, the native image didn't, and they were stuck. And it was a problem. So that was my first, maybe this isn't ready yet. But that was early on with GraalVM. In, I think, 2018, the Spring team started doing some experimental work with GraalVM, and they put it into a package called Spring-Native, where they're putting some of these hints and making it so that we could build native images with GraalVM. That was experimental. So your set was kind of limited. With Spring Framework 6 and Spring Boot 3, we said, hey, our projects can now use Spring Native. But there were still some hiccups because not all of the dependencies that we were using were supporting this native image. What's happening under the covers with a native image is normally on a JVM, we generate bytecode. That was the promise of Java. Bytecode, write once, run anywhere. They said it was going to be running on your toaster, right? With Spring, or with Java 1.3, the hotspot JVM, the team at Sun, I think at that time, said, hey, we found this hotspot. We found this code that you're executing a bunch of times, the hotspot. What they did in the JVM was they optimized that bytecode and they converted it to native code for whatever operating system and architecture it was running on the other side of the JVM. We've been doing that since the 90s. So this has been around for a long time. That technology of converting the bytecode down to native code has been around since the 90s. It's been around for a long time. The team at GraalVM Labs over at Oracle, they said, why don't we do it for everything? They take that bytecode, they convert all of the bytecode to native code for that operating system and that architecture. The trade-off is that code can't run anywhere. It's optimized. So if I build on this machine, which is Apple Silicon, Darwin, that code will only run on Apple Silicon, ARM64, and Darwin. We can get some flexibility with native image build packs, right? We can compile for different platforms, but that code is optimized for that platform. Make sense? Any questions on that? This is cool. The promise is faster startup, smaller footprint, and improved performance. The improved performance, I'm going to put in asterisks, right? For some workloads, native images are great. For some workloads, it's a great idea. But the JVM is still amazing. So not all workloads are suited for native images. Cool? So let's get started. Is anybody going to play along? If you've got your laptop out, this is what you're going to put in. If you want to play along. We're not doing a whole lot of coding. It's going to be pretty straightforward. And we're going to build a Spring Boot image. I could go and do this at start.spring.io, but this is what we want to type in if we want to build that same image, and it's going to generate a project for us locally. I'll leave that up if you want to try that. So while we have at least one that's going to stand it up, what's your experience with native images? How many people are taking native images to production? 0 hands. All right, how many people have played around with native images already? 0 hands? Yeah, ask.
I use Rust also as well with Java. I work on Rust.
Okay.
We build the bytecode for Mac OS or Linux and stuff. Can you call that as a native?
You could, yeah. 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 Using Rust, right? You can build target native images, but yeah, for Java, right? Java native images. Anyone? All right. These are fast images. So we're building a simple application here, and the first thing I want to do is show you like the difference. So I'm going to build this. I'm going to copy this same thing. I'm going to go over here. I'm going to go to a different one. Oops. And I'm going to do that same thing. So download it. Oh, I didn't even check my Wi-Fi. Oh, I should probably do that. That's a speaker fail. Let's see if we can fix this real quick. I travel a lot. So in my bag, I have 3 phones. I have one for T-Mobile, I have one for AT&T, and one for Verizon. We'll see which one works. We'll see if any of them work. But because I travel, I have 3 hotspots, just to make sure. So let's try this again, now that I have a connection. Fantastic. I've got a Spring Boot app. Just like I went to start.spring.io, I've got a Spring Boot app. And let's run it, right? Let's see that it works. MBNW Spring Boot run. This is a great way to start your app out of the box. It works. We can see, hey, here's how long it took to start up. It started up pretty fast. I can say Java-version. I'm running Java 23. And yeah, now let's build an image. That's what we're trying to do. We want to get these native images to production. How many of you are taking containers to production? You're using Docker containers or Kubernetes or Cloud Foundry, right? Fantastic. This is kind of the current artifact that we build, is that container. So one of the things, actually I'm going to go back here. Friends, don't let friends use Dockerfile. Right? If you're using Dockerfiles, you're doing too much work, and you're putting more work on yourself in the future because you've got to patch and maintain. And there's a lot of tips and tricks that are included out of the box with Spring Boot and the Spring Boot Maven plugin. You get that, or even the Spring Boot Gradle plugin. you can build images with all of the tips and tricks to optimize that image out of the box. It looks like this. So I'm going to build this image. I'm going to build it, and I'm going to give it an image name so we can take a look at it. What? Oh, there we go. So what this is going to do, hopefully it's already got the image, it's going to use the build pack. It's going to use a Paketo build pack, which is a Docker image. It's an OCI image that knows how to build OCI images. So the output of this Spring Boot build image is going to be an OCI image that I can take to production on Cloud Foundry, on Kubernetes, or Docker, or whatever. So now I've got this new image that runs that same app. It'll be there. But the one thing I want to look at is I want to do this. I want to do Docker images, pipe rep, Devnexus. And I want you to see the size of that image, 517 megabytes. The reason is bytecode is awesome. Bytecode is small. Yes, Spring Office Hours, that's the theme music. That's awesome. The JVM is included in this image. In order to run that bytecode, it adds a JVM. So it has that JVM layer in it. But now what we're going to do is we're going to build a native image. All I'm doing is adding that -p native. And I'm going to give it a name so we can see which one is which. The problem is, the concern, just like it was in 2025 or 2015, was when I build these native images, how do I know? How do I have confidence that the JVM image that I take to production is going to act the same way as that native image? No worries, it's okay. Yeah, I mean, this is a safe place. This is a safe place. So this is building. The other trade-off of native images is that native image, it takes a while. It takes a while to analyze all of that bytecode, to optimize all of that bytecode. All the dependencies that I bring in to this process, it's going to see, are you using any of that code? If it's not using the code, it throws it away. There's no point in optimizing code that you're never using. So it gets rid of stuff that you're not using, and you get just a fully optimized native image. If I was on a Windows machine, the output would be a .exe file. But what we have in that native image is we have all of our optimized bytecode for our app. We have the parts from Tomcat, right? Because we need that server, that embedded server, to run this application. So it optimized Tomcat and all of its dependencies. And also parts of the JVM substrate, just the things that we need to run in production. So it's bundled all that into a single file, and then we took that single file and we put it into an OCI image. That's what we've done. So now let's take a look at our images again. We'll see them both. Here's the first thing. The first thing is that size. The native image doesn't have to include the JVM. So the native image executable, it's larger than the jar file that you would take to production. But that is smaller than the bytecode combined with the JVM, combined with everything else that you would take to production. So these container images are smaller as well. So these are just another reason why you might want to go down this native image path. What I've been telling customers, I'm a developer advocate. I work with Global 2000 customers all over. And the thing that I've been saying since Spring Boot 3 was released was build the native images. Build the native images in your pipeline, because in development, your local development, wouldn't it be nice to be able to have your teammates' service installed and running? Or installed and scaled to 0? These services start up fast. Let's do this. Let's -p native compile. I'm going to build this native image running locally for ARM64 for Darwin. I'm going to build it again, but I'm going to run it locally. I'm going to show you how fast it starts up. The first time, I need the native image kit, so I have to do SDK list Java installed. I'm going to switch to the version that has the native image kit. So I'm just changing. When I'm in the build pack, I don't need that. So SDK use Java. In the build pack, it pulled down the JVM that it needs. So I didn't need to have the native image kit when I'm building the native image inside of my build pack. Now let's try that again. We're going to do this. I was a little nervous because there's actually a bug inside of the M4s that sometimes doesn't allow us to do this native image. There's a sig fault error that gets thrown. Josh is really upset about it. It gets fixed. There's a workaround. It gets fixed in Java 24, but with Java 23, it does not. It shows up sometimes. I've been very lucky. It could show up now, but so far so good. Again, that native image process, this is part of it. There's trade-offs here. You don't want to be doing this on your local machine very often, but I'm going to start it. Target demo. So it started up in 0.051 seconds. So the first time we started up, when I did Maven Spring Boot Run, it was like a half second. It was 500 something milliseconds. Significant performance improvements. Super fast startup time. So if we're all working on the same big A application, and we convert each of those bits, those microservices, into native images, we can actually scale them to 0 using something like Knative or Keta. We can scale them to 0. So when I worked at Garmin Connect, there was about 117 microservices that we were taking to production. Being the kind of person that I am, I wanted to have a Garmin Connect running. I wanted to have that big A app running with all of its microservices. You could not do that on an 8 gigabyte laptop at the time. But today, with these native images, you can, because I could scale those services down to 0 on this laptop. This is a bigger laptop, but on a normal laptop, I could have 117 microservices deployed to Keta or Knative and scale to 0. And then when I access it, it'll give me that extra 0.051 milliseconds to stand up, and it'll be okay. For local development, this is a really cool idea. And this is what I've been pushing. Build those native images so that your teammates can have your system running locally. It's powerful. It's a great way to learn about the rest of the application when you can get it to run on your laptop and you can do those end-to-end tests without having to do a git commit, wait for the pipeline to go and get to the end-to-end tests before you get any feedback. Right? The faster we can get feedback, the faster we can do things, right? That short feedback loop. So what I'm trying to say is build those native images. It makes it easy for your teammates to download them. It makes it easy for them to run on their laptops, and they can scale it to 0 and start up really quickly. So even if you're not taking it to production, there's tons of developer productivity benefits with native images. But on top of that, going to production with native images can have significant improvements as well. The smaller footprint, faster startup. If you're doing functions in the cloud, we're paying per millisecond billing. So 0.051 is 10 times less expensive than 0.5 anything, right? And those milliseconds matter. I don't have cloud money. So this is native images. These are some of the benefits of why we want to go build native images, but we want to have confidence. How do we make sure that the JVM image gives us the same results? How do we ensure that? It's tricky, but I can say that, hey, ensuring that feature parity is the key. Performance isn't going to match. It's either going to be weighted towards the native image side or weighted toward the JVM side. It's not going to match. That's not the important thing. The important thing is that when I put in a value, I get the same output. That's the kind of parity that we need. Verify that the native image behaves like the JVM image, but we have to have testing. This is, in my works, in my perspective, this is the number one thing that's preventing teams from going to production. They say, hey, we don't have good testing. The better the test, the better the confidence for anything. So if you're going down this native image journey, but it's the same with anything. If you're wanting to upgrade your JVM, right? How many times have I heard, well, we're stuck on Java 8 because we don't have the right amount of tests to go to Java 17. But they're still doing feature releases all the time, right? Like, how do they feel confident about those feature releases? Better tests, better confidence across the board. So this is a strategy that I started using early on with Spring Boot 3 and Spring Framework 6. And it was right around the time where test container integration came to the Spring Boot ecosystem. Test containers has been around for a long time. Test containers is a nice way. How many people are using test containers? Test containers. It's a great way to stand up a database as part of your test, as part of your integration test, especially. Stand up a database, execute against this image, so you don't have to have Postgres and Oracle and Redis and Neo4j. You don't have to have all those installed on your laptop. You can have an image, a test container, stand up. You can even implement your own schema or load it with test data, then run your tests against the same type of database that you're running in production. Again, that parity with production. But I get that fast feedback loop in development. This is why we like test containers. But there's more. Test containers is really just a way for me to interact with images. This strategy uses test containers not to stand up a database, but to generate an image. And then we'll validate it with integration tests. So now we're going to get into the fun stuff. If you're playing along, we're going to add 2 dependencies to our project. We're going to add, and this is my character flaw, is before I had a different dependency in there. Spring Boot has release trains. Release trains make sure I get the right dependencies. So I've completely changed this, and I'm crossing my fingers that this is going to work. Instead of pulling in rest assured, which is what I need, I pulled in the Spring RestDocs rest assured dependency in order to get a version of rest assured. Rest assured is just another testing framework. It allows us to make tests. RestDocs. How many people are familiar with RestDocs? Not at all. RestDocs is a way to generate your documentation from your tests so that your documentation always matches your tests. Run your test, capture the output, and you can say, hey, here's what your test should look like. Here's what the documentation. Grabbing, making sure the documentation always matches what actually happens in your code. So as a part of your pipeline, you might want to run your tests, generate your docs, and put those into your artifact so that your documentation lives with your code in production. It's fun. So I'm using Spring RestDocs. I'm not going to go into Spring RestDocs, but I'm using it to pull in the proper version of Rest Assured. So now I'm going to jump over. I'm going to cheat here because there's a lot to cover. How are we doing so far? Does this make sense? CI. How many people have integration tests? Integration tests. So for all of your pipelines that go to production, we have unit tests, then we have integration tests where we're connected to the different services. Do you have any end-to-end tests? Do you have end-to-end tests like, hey, do the whole thing, a smoke test front to back? There's a lot of testing. The more testing we have, the more green lights, confidence we have, the better it is going to production. But native images is tricky. How do you test native images? What might be a strategy for testing native images? We have a small audience, so not a lot of experience going on this path. So I'm here to share it with you. This is what we've been doing. I'm going to jump over here. And I've added the 2 dependencies, our Maven Invoker. Did I have that the right version in the test? Yeah. So I've added Spring RestDocs, Rest Assured, and I've added this Maven Invoker. The Maven Invoker lets me call Maven. It lets me run a Maven POM file. It lets me execute specific targets in that POM file. Rest Assured is my framework for writing tests. So the first thing I'm going to do is I'm going to build an abstract test. So I've got some test code I copied. My fingers, like I said, are crossed. I just changed this before coming. So what we're going to do is we're going to build a set of abstract tests. We understand the idea of an abstract test. This class won't run. I'm putting a test here that I want to be able to execute against the JVM image and the native image. So when I run my unit tests, when I run my integration tests locally, I can execute that and I'll have some results. But when I do my integration tests, I want to have a test that runs, again, unit tests for the fast feedback, but in integration, if I'm going to build these native images, let's test it. Let's build that native image there because they take longer to build. And let's test that native image with the exact same tests. How does that sound? This is the way that I give confidence to teams that are taking native images to production. Instead of the traditional, hey, we're taking a JVM image, yeah, it works. How do we make sure that the native image is going to get the same results? We're going to make sure that it's feature parity, not performance. I'm not doing that today. I'm talking about the inputs that you put into the JVM, you're going to get the same output on the JVM and the native image. So that's this abstract test. Let's just walk through. I'm going to bump that up because I can't even see it. There. So, again, not a live coding session because I'm nervous. I'm nervous about this working. So I had a logger. I've got a port so that I can connect to it. I'm going to need that port 8080, whatever port it's starting up on. I have my request specification. This is only there because I'm using the rest assured REST docs if I want to generate documentation. And I'm getting the Docker network. Again, I don't think I needed that. That's where if I wanted to add test containers to that native image, I can do this with if I have something that's running against a Redis. I use that network to add that Redis so I can connect to it and run it. Now what I'm going to do is, this is for my documentation, I'm going to build a test. This test simply says, again, using rest assured's terminology, this test says, hey, we're going to do a get against the actuator health endpoint. That actuator health endpoint hopefully returns a value of up. We want it to have a 200 status. You with me? Let's go take a look. This should work locally. MVNW spring boot run skip test. Fantastic. Let's go to localhost 8080 actuator health. We're good, right? So that works. But that's not in my unit test. This is just an abstract test. Let's take this abstract test and let's build an application test. So in this application test, we are extending that abstract test. So hey, I'm going to go run that test. I feed it a little bit, say, give me a random port. So I'm changing that port value so I can run more than one in my CI/CD pipeline. I don't want to have port collisions. And I'm passing that information in. So this test, which extends that abstract test, is going to run that test, but this is just with a JVM. So this is my unit test. Fast feedback with the JVM. Let's run this. That makes me happy. So I ran that with the JVM. This is my unit test, but it used that abstract test. Now we're getting into the meat. This is great. This is just like you're doing today. You have unit tests, you're taking it to production, but we want to test that native image. Rest assured makes this easy with these test containers. So now I'm going to go and build a native image test. I'm going to close this so we can see. So I've taken some liberties here. I'm not going to live code this. I tried. I couldn't do it in the amount of time that we have. I'm not fast. You might know my teammate, Josh Long. He's fast. So this is my native image, and I gave it that IT tag so that it'll be ran as an integration test. I don't want this to be ran every time I do my test locally. If I do this, MVNW clean test, that IT test should not run. Okay, fast feedback. So we're in good shape. So when you're doing your Maven clean package locally, you're not going to execute that integration test. This integration test assumes, and just because of that IT, that's the convention. This integration test assumes that you've got a Docker image. In order to use test containers, you need to have a Docker port that you can connect to. And that's it. What we're going to do is we're going to create this image future. So hey, I want to use an image, but I haven't built that image yet. So I'm using the test container harness to actually build an image. I could build a JVM image. I could build a regular OCI image. But in this case, I'm using it to test that native image. I'm saying that the confidence that I get from running my unit tests against a JVM is going to be the same, whether I put it into a OCI image or a Docker image or not. Stay with the same JVM, and you'll be in good shape. You can have that level of confidence. I am surprised. How many people use a different JVM locally than you take to production? Anyone? Yeah. Can I ask you why?
Because I work on different projects. I have like a mini versions of Java in my local.
Good, that's exactly right. Do you use SDK-Man by any chance? SDK-Man, for those of you that don't know, this is a very, very amazing tool. I already showed it. SDKman.io gives me the ability to switch between JVMs as I switch between projects. I'll show you another cool thing. In this project, I've got an SDKman RC file. If you've got SDKman installed, inside of your project, you can say, this is the JVM that I want you to use. And if you're using SDKman, it'll automatically switch to that JVM. So that if I'm using Tamarin or Zulu on different projects, when I go into that project that has a .sdkman RC file, if it says Zulu, it'll pull in and you'll start using Zulu. But now because I'm here, that's the version I'm using. So let's go back. Let's go back to our native image test. This is what I'm trying to accomplish. So let's walk through this. I'm going to create a file. I want to just make sure that I'm on the right path when I'm doing CI/CD. Sometimes those tests are being ran in a different home. If you've got fork tests or parallel tests, this just makes sure that I'm on my project's target. I'm grabbing that, I'm looking for that Maven wrapper. Again, this is taking some liberties, assuming that you're building it with Maven wrapper, but the same process works with the Gradle wrapper. I'm using that Maven wrapper file as this is the base of my application directory. From there, I'm giving it a name. That name could be anything. I'm gonna take a chance here. I'm gonna remove this, just because I want to see it. I'm gonna call this DaShaun local test, and it could blow up. That's fine. I don't know. We'll see. And I'll give it latest. What could possibly go wrong with changing before you go? I didn't run this before, so we'll see. So I'm going to set these properties. I want to just make that the name. This is something I can pass in as a property for my Maven build image. I'm going to pass in that image name. Cool so far? So I'm just setting myself up to build this image. So here's my request. I'm going to call this Maven Invoker. I got this from the Maven Invoker dependency that we pulled in. And I'm connecting to my local Docker host. That Docker host could be an external Docker. So here's another tip. If you're building things, if you've got pipelines that are running inside of Kubernetes, you're running things inside of an image, sometimes you need to build an image inside of an image. And we had this thing a long time ago, Docker in Docker has been around for a long time. How do you connect to the Docker socket without giving it privilege? There's some concerns. The other option that you have is you can provide a Docker host. Spring gives you that option when you're building images. You can say, hey, I want to build an image, but I don't want to use this machine. I don't want to use this image. I want to use a Docker host that's been provided. And you can use an external Docker host. So for me, I like to use Karifi. I like to use Kubernetes on my laptop, and I have my own concourse, but that's running inside of Kubernetes. So if I want to do Spring Boot build image, I can't build it inside the image without doing the whole Docker, giving it more access than it needs, and providing that same socket, because I'm in Kubernetes. So I provided a Docker host. I run Docker on a different machine. I give it some user passwords. I do TCP. Just hear me now, listen to me later. You'll run into it, and now you've got that answer. So I'm passing in this Docker host. Again, it can get that from the environment. And then I'm passing in the file. Hey, here's my PALM file. And I'm calling the same image, the same dependency that I called before, Spring Boot build image. From the Maven wrapper, and we're set. I pass in those properties. So we're going to build an image. But this is in my native image integration test. I don't want to do this all the time. Once it does that, once it builds the image, it returns the image name. So it takes its time, build the image, it returns that name as a future up here, and it uses that as a test container. It starts up a test container to have that application running. So instead of attaching a Redis or a Postgres, I'm actually attaching my application as a Docker image. As a part of my test, instead of standing up a different database, which is kind of the default use case for test containers, I have generated an OCI image. If you've got, this is another strategy, if you've got agents that you're running, sometimes that, not picking on anybody, Datadog or App4j or App Dynamics, like they add those agents to the JVM. Sometimes when you add those agents, you get weird behavior. Sometimes you want to validate how much overhead is that agent providing, right? There's a lot of claims, oh, it's going to be less than 10% for most use cases, but how do you validate that? I use this same strategy. Give me an image, attach that JVM. Okay? So that's just the setup. With that container that I just created, I start up, and then I run my tests. Oh, and it says start that image. But then from there, it's just going to run the same test because we extended from that abstract image. You have a question?
So basically, it's wait 10 minutes for the image to come up, and then it's going to time out there on line 75.
Yep. I'm just giving it a timeout. So I'll tell you the story behind that. I was at a conference. This was first time that we were using native images. Actually, it might have been pre-Spring Boot 3. Actually, I know for a fact it was pre-Spring Boot 3. And I have the little story here. And I was on stage. I was new to the team. I think we were in New York. And I'll find it. Oh, here it is. 2022, before it came out. And I know it was before it came out because I saw the version somewhere. Here we go. Yeah. RC2. So but I was on stage. I had a 40-minute talk. I had an old machine. I was on stage, 40-minute talk. I was trying to build a native image. I was using an Apple Intel, and I was just doing my demo. Normally at that time, it took about 1 minute and 45 seconds. But I had my IDE open, I had my Docker open, and I was on stage for the first time, and my boss was in the back of the room. And I did the Maven Spring Boot build image, pnative, go. And it spun. And it spun. And this person, Sergey, the creator of test containers, he was in the back of the room too. And it spun, and I'm doing the dance. I'm like, oh, what's going on? How come this is taking so long? 8 minutes. What is even happening? What did it say? I'm pretty sure it took like 10 minutes.
That's still deep too, it looks like.
I added onto it in Tel Aviv, but it felt like forever. The native image took forever to build, so this is where I started using that external. I was using Test Containers Cloud so that even when I was on a slow laptop, I could use Test Container Cloud to build that image and test that image. So it was right after the session that I went out and I sat down and we came up with a solution. And I've been using this solution ever since. That's just a little background. That's why the 10-minute timer's there.
So we're trying a future, therefore you have someplace you have to be waiting for it to say, I'm done, and that can allow you to go on with the rest of the code.
Absolutely. So, hoping that my code gets done and I can generate this image in less than 10 minutes. Fingers crossed. Again, I'm making changes as we go. So, does this make sense? I'm going to build this native image. I'm going to run this set of abstract tests. I can add all of the abstract tests that I need to feel confident that I'm going to production. These are REST endpoints. I'm just hitting the actuator health endpoint. But does that make sense? Yeah? Would you feel confident if these tests, this abstract test, matches what you're doing in your unit tests? I think so. Let's cross our fingers and let's hope. So let's just go up here and everybody take a deep breath. Let's run it. So it's doing its thing. It's going to do the first thing. Let's go build the image. So it's using the Maven executor to go and using the build pack. Remember, friends don't let friends use Docker files. Go use that build pack. Generate, it's now downloading the proper version. It needs the JVM image with the native image kit. It knows that because I gave it the pnative. And it's going to build that image. It's going to still do all the things, but this is part of an integration test. You can do this on your pipeline. This is one way, one strategy that I've been using since 2022 to give yourself confidence in running native images in production. Another strategy for that confidence is You don't have to trust your pipelines to cover all the things. Take a native image. If you've got 10 instances running in production, 10 JVM instances, take one of those instances and run it as a native image. And just validate. Send 10% of the traffic to that native image and see. This is the same strategy I'll tell you. You can do a canary deployment. Do partial traffic. Same thing I'll tell you when you upgrade to Java 24 in a couple of weeks. When you want to change, you want to do evaluations of your garbage collectors. Same strategy. Send some of the traffic, but this native image integration test, this is valid. You need good tests in order to go to production with confidence. We're still building. Oh, no, we're green. It worked. I knew it was going to work. I knew it was going to work. So this is it. We're in good shape. It built the image. It used the image to run the test, and it ran that same set of tests in our abstract tests.
Are these Rust calls that you're making for your tests?
Yes.
Because you can't exactly invoke methods from the outside, or can you?
So I'm invoking them from the outside. So it's my rest assured client is calling the running image that I just created. Yeah. So no mocks. It is calling the actual code, and this is how I have that confidence of running native images in production. Let's go. I'm feeling good. We got a little story time. Let's go back to our tests. I'm going to hit this. These are the things I want you to remember. Friends don't let friends use Dockerfile. You can't do cool things like this if you're also having to maintain Docker files. Building native images, building JVM images. You can use the same Paketo build pack to build both. And those Paketo build packs are being maintained by the Paketo team. You don't have to maintain Docker files. Better tests is better code confidence. That's it. There's no ifs, ands, or buts. I get it. If you don't have tests, but you want a little bit of confidence, I'm showing you a shortcut to give yourself confidence with native images. I talked about Spring REST docs. This is a very cool tool. If you want your documentation to always match your code, how many times have you gone to a cool new API and their documentation didn't match? Oh, I expected this to happen. The documentation says this, but it didn't work. How many times does that happen? I hate that feeling. And if I'm providing an API, I don't want you to feel that feeling. That's why I'm a really big fan of Spring REST docs. And Spring REST docs is what I use to pull in REST assured. Integration test. Do it as part of your integration test so we can validate the native image. Don't have to worry about the lifecycle. We can run the exact same tests against the native image that we ran against the JVM image. And we're using test containers to generate that image. Thank you. My name is DaShaun. I'm a Spring Developer Advocate. I'm here for any questions. Yes, you that I've never seen before in the back.
I did, load and performance testing for a long time for big enterprise clients, and I love what you've done here in really tying together the whole, sequence of testing. But at the tail end, I found myself do you have any tooling that you use just locally to spin up 10, 15 external clients that you can do?
That's a great question. Let's see what we have here.
Just to have a sense of how load impacts the CPU memory.
I'm a fan of having Kubernetes running on my laptop. But I don't want to install a Kubernetes, especially on Mac. Although I have used or tried to install K3s, a lightweight Kubernetes, Docker is pretty cool. Docker by itself has Kubernetes that you can turn on. There's a button over here. You can say, hey, I want Kubernetes. Just enable it. And it gives you a Kubernetes cluster. And you can tweak it and fine tune it. There's some restrictions, but it's still pretty powerful. There's two other options that I use. I use Kind, which is Kubernetes in Docker that comes from a SIG of the Kubernetes CNCF group. And there's also K3D, which is K3s for Docker. So I can use K3D to deploy a cluster to my Docker container. But I run that locally. And on top of that, I run Cloud Foundry. So this, we have Cloudflare. Let's do something interesting. let's take the app that we just built. And I don't know if it'll work. Let's do this. I'm going to go here. I'm going to take the app that we just built. I'll do it on this one, MVNW. Oh, wait, no, I have image. Docker, images, pipe rep, Devnexus. All right, I've got a native image. Let's do that one. Where's my mouse? I've got a native image here for Devnexus. There's 218 megabytes. Let's do CF apps. CF orgs. CF spaces. CF create space. -O, DaShaun, -live. -S prod. Oh, sorry, prod. And then let's target that. So this is inside of my Kubernetes cluster. I'm running Cloud Foundry. And now if I do CF apps, there's nothing there. What I'm going to do is CF push, we'll call it Devnexus, -- Docker, DaShaun, Devnexus. Did I call it native? Uh-oh. Did I do that right? -- push app. I swear it's -- Docker. Unknown flag Docker. What? CF -- Docker - image. So now I'm just taking that image that we just created and I'm throwing it up to my Kubernetes cluster. But I'm also getting some routing. So I gave it an app name. What did it say? Failed to fetch. Oh, because I didn't push it. Let's see if we can do that. Docker push is trying to pull it down from DaShaun, Devnexus, native. Push, what? Docker images. Oh, 2025. We're having fun. We got some time. So we're going to send that 218 megabyte image. We're going to send it up to my Docker hub, which is where my Kubernetes cluster is looking for the image.
Now, this is just work with Spring. Would this also work with Spring?
Cloud Foundry, well, the native images also works with Spring. The same, I can do build packs. I don't have a build pack plugin for Spring, I don't think. That's a good question, but I can still build Spring apps into native images. I can still put Spring apps into OCI images. And I can run those Spring apps on Kubernetes if I've got a container. So this is going over my hotspot. It'll take a second, but this is how I do it. I run these images locally. I told you the value of having these native images that start up fast. I'm not going to scale this to 0, but I'm going to have this image running locally on my laptop so I can see how it interacts with everything else. This is one of the other benefits of building these native images. So now let's try that RCF push again. Did I do 2025? Yeah. So Cloud Foundry takes care of the routing. I'm going to have an endpoint, and we might even be able to see it. All right. I do Docker, or nope. CF logs, Devnexus. I see it was up and running, and it took even less time, 34 milliseconds to start up. Like, this is great. So that's how I do it. I have my CF apps. I can see there's my URL. Let's see that app running locally, along with all the other cool things. Actuator, health. Fantastic. So we took that native image, we pushed it to our local Kubernetes cluster, and we're in good shape. Good question. In order to do that, I use the kind Karifi. Karifi on kind, there's a nice little deploy script that can stand up your Kubernetes cluster, and deploy Karifi, so you get all this cool networking included. Any other questions? Fantastic. Hopefully this was helpful. My name is DaShaun Carter. Thank you for your time.